or the next problem. And once again, spend your time really studying the classes before you, and which is what these questions are meant to kind of guide you into thinking about. Don't just blindly start running this code without doing that analysis first. Okay, so if we look at it, there's two instance variables for methods. The in class doesn't add any new instance variables. And if you look at the methods, it has the exact same 4 method names. So it overrides all 4 of them in this case. So n has its own special behavior in every instance. Okay, let's go through this. Once again, how many instance variables does an n object have? 2, x and y. What does it inherit? Everything but the constructor. So x, y, fun go back to string. What does it override? Well, all 4 methods. Does it truly extend? No, not at all. It doesn't add any new instance variables or any new methods. Now, as far as output, by the way, let me say again, I've said before, you have to be careful that the code even compiles, but the only time it won't compile is if the subclass adds on new methods and you're trying to call that new method with a superclass reference. So if n had a new method and you try to use an m reference to access it, it wouldn't compile. And that's not the only way it could fail to compile, but that's the biggest thing to look at with a structure like this with inheritance. But like we already said, there are no new methods, so that you don't have to worry about that. And that is kind of the point to this last question. Look for new things in the subclass, because that's going to, you got to be careful about, when you check for compiling. Okay, let's go through this. First, create an m object, and the constructor there sets x to be 8 and y to be 1. Done. You call the go method. Which go method? Well, this is easy, because it is an m reference and it is an m object, so certainly you're calling the m version of every method call. So you call the m go method, and you get the y value, which is 1. What's tricky about these, by the way, the return type is double. Why? I don't know. To see if you're paying attention. So the answer is not 1, actually it's 1.0. Then you call back, and it's going to the m back method, which recalls the fun method. Which fun method? The m fun method, because once again, it's an m object. So you get the x value, which is 8, but it's a double. And then you call the fun method directly this time, so you get 8 again, 8.0. And then you call the toString method, which returns x and y, so 8 and 1, and there you go. Now it gets more interesting. Now, once again, it's an m reference, and so the compiler will look in the m class for all these methods and find them, so it compiles. But then when you run it, you're going to run the n version of every method, and just keep that in mind. While we run this code, Java is going to dereference every method call by, when I say dereference, you're basically going to go and access this n object that stores 8 and 1, and get that n object to do what we wanted. So we asked it to, we call its go method. So we call, go method. It says super.back. Well, okay, fine. It says super.back. Therefore, we're calling the back method found in the superclass. But then that method calls the fun method. Which fun method? Well, it is an n object, so we're going to call the n fun method. That's what I'm trying to stress. Is it doesn't matter where the method caller originates from. You're going to call. It's going to look in this subclasses, in the subclass, for the implementation to run, the version of that method to run. And so you call the fun method. You're going to call the in fun method, which returns 7 as a double. So that first line of output is going to return a 7 as a double once again. Now we call the back method. We look in the in class. It returns 2 as a double. Then we call the fun method, and this, of course, is the in fun method. Then we call the toString method, and this toString method overrides the original, but all it does is call the original, which is pointless, frankly. And so the last question we have is, what method could be removed in the in class and get the same behavior? Well, that would be the toString method. It had no point at all. All right, that is all. Soon we'll start adding on instance variables to the subclass.